Welcome to Indefinite Integrals, Lesson 6, Integration by Parts, Substitution, Both, or Neither, where we try to decide whether we should integrate a problem using parts, substitution, maybe using both, or could even be that neither is the correct answer. Integration problems don't come with a sign saying, hey, I'm done using parts, or I'm done using substitution. So we have to just rely a little bit on our experience from what we've already done, and that's part of my job is to give you more experience, and then to give you some likely clues that we've already talked about, as to, look for, if it's by substitution, look for a part of a derivative going on there somewhere, or, just if it's the product of two functions, it could possibly be by parts. So I'll give you a couple guidelines, and then we're just going to dig our heels in and do the best we can. So let's go ahead and look at these guidelines. You want to write them down? You may. I'll flash those up for you right now, and you go ahead and pause if you want to write them down. Here they come. I think step number 3 is really important, to just try to persevere. Just keep on plugging away until you can find something that works. Eventually you'll get there. I believe in you. Here's your first example. The integral of x cubed e to the x squared. Now if this were just an e to the x, we could really do this easily by parts using tabular integration. But it's e to the x squared, and that's going to get a little bit more complicated. So what is the most complicated thing on there? E to the x squared. So let's try to simplify that. How can we simplify that a little bit? Oh yeah, absolutely. Let's go ahead and do that. We're going to use a substitution, make this a little bit easier. We want to make that exponent so that it works a little bit better for us. So our u is going to be x squared. Our du, 2x dx. Hey, wait a minute. We definitely don't have a 2. So we'll change this to 1/2 du equals x dx. Now we don't have an x, we've got an x squared. But we could rewrite this as the integral of x squared times x, that's x cubed, e to the x squared dx. Ooh, that's kind of cool. I can replace this x dx with what? Half du. So we're going to get rid of this, and we're going to write 1/2 integral du here. Hey, wait! Wow! Look! X squared. That's u. U e to the u. Oh, I know you guys can recognize that as integration by parts. F will be u. G prime will be e to the u. F prime will be 1. G simply e to the u. So 1/2 u e to the u minus 1 times the integral of e to the u du. So 1/2. Actually, that should be 1/2 times all of this, shouldn't it? Yes, because the 1/2 is out in front of this parts part. So 1/2 u e to the u minus e to the u plus some constant. There you go. Oh no, we've had to replace back in. So 1/2 x squared e to the x squared minus e to the x squared plus c. And I'm not saying you have to do that. That's fine for me. But if this were a multiple choice question, it would probably be 1/2 e to the x squared times x squared minus 1 plus a constant factoring out an e to the x squared. I'm just saying that's probably what it looked like. You could leave your answer like this and I would not have a problem with it. But you know, sometimes reconciling your answer with the multiple choice answer can get a little complicated. Alright, let's go ahead and move on to the next one. Alright, you got the integral of e to the x quantity cubed minus e to the x quantity squared. All that times e to the x dx. Whew! Way too many e to the x's going on there. If we could just get rid of those, this problem would be a whole lot simpler, wouldn't it? So how could we get rid of e to the x? Well, we could make u equal e to the x. Then du, what's the derivative of e to the x? Well, of course, e to the x dx. Hey, sweet. We're going to put du right there. So we got the integral of u cubed minus u squared with respect to u. Oh, come on. It couldn't have been that easy of a substitution. Yeah, sure. Okay. Add 1 to the exponent. Multiply by the reciprocal of the exponent. Add 1 to the exponent. Multiply by the reciprocal of the exponent. Plus c. So 1/4 e to the 4th power minus 1/3 e to the e to the x raised to the 4th power, e to the x raised to the 3rd power, plus c. Yeah, it was really that easy, just a simple substitution. Next! Oh my. No, not back to trig. Yeah, sorry, Brian. Guess you should have paid in trig class. Oh, wait. You didn't have trig class. Good luck with that. Alright, let's see if we can change this around a little bit. What's the reciprocal of cosecant? Good. So we got the integral. We'll move this up into the numerator as sine x. And everybody knows what 1 minus sine squared x is, right? Don't you? Sure. Cosine squared x dx. Alright. Let's see what we can do there. Sorry about that long pause, but I actually saw 2 different ways to do this integral, and I had to make sure both of them worked, and guess what? They both actually did work. So I gotta just throw that out to you right now. What do you see there? Well, I see that the derivative of cosine is sine, so we could possibly use substitution there. So why don't we go ahead and do that, and I'll show you the alternate method that I found in a minute. So u is going to be cosine of x du equals negative sine x dx. So negative du equals sine x dx. So this could be rewritten as the negative 1 times the integral of 1 over u squared du. Trying to extend the page. And that would be negative integral of u to the negative 2 du. Add 1 to the exponent. Negative 1. Multiply by negative 1. U to the negative 1 plus a constant. That would be cosine of x to the negative 1. No, that does not mean... No, wait. I'll tell you what. I'll do it this way instead. Okay. That would be 1 over u plus c. So 1 over cosine of x plus c. And that would be secant of x, because the reciprocal of cosine, secant of x plus a constant. Now I'd like to show you the other way I saw how to do that. I saw this as sine of x over cosine of x times 1 over cosine of x dx. Okay, and that would be tangent of x times secant of x dx. And what is the antiderivative of tangent x, secant x? Sure. Secant x plus c. So you could have either done that by substitution or done that by neither and get the answer secant of x plus c. Pretty tricky there. Next one, arc sine of x, also known as the integral of sine inverse of x dx. We can't write this as two functions, so we can't do it that way. There's nothing to substitute. Okay, let's try integration by parts. Sine inverse of x, g prime will be 1. So f prime equals 1 over the square root of 1 minus x squared. And g would be x. So that would be x sine inverse of x minus the integral of x over the square root of 1 minus x squared dx. Now let's try to do this by substitution. U equals 1 minus x squared. Du equals negative 2x dx. Negative 1/2 du equals x dx. Here's my x dx. We're going to replace that with a du. So x sine inverse of x minus, actually that would be plus the integral, 1/2 the integral, of 1 over u to the 1/2 du. Alright, go ahead and rewrite it, and go ahead and try to find the antiderivative. I'm running out of time, so you're going to have to pause it and try it on your own. Here's what I did. I moved u up into the numerator and made it a negative 1/2. Added 1 to that exponent, got 1/2, multiplied by the reciprocal 2. And final answer, x sine inverse of x plus 1 minus x squared, square root of that, plus c. This does conclude Indefinite Integrals Lesson 6, Integration by Parts, Substitution, both or neither.